Wild to wild and everything in between. Today's program we're going to be talking to you about the valve train and how to periodically check your motor. So stay tuned. Now what I'd like to get into is a couple ways of checking or monitoring your motor throughout the course of the year. I use a compression gauge right here. What I do is every couple months I go in there and use the compression gauge to get a check on each individual cylinder. And let me show you how that works. I took a check on 530, they averaged 147.3. On 8.7, they averaged 166.5, 9.27, 176, 11.5, 175. What I've done is I try to monitor it every couple months. I always do it right after I get the motor built, and then before I put the car away for the winter, I check it again. And this is a very good way to monitor your motor to see if the compression, like in this case, once the engine started to break in, you can see how the compression actually came up. That's the way to check the inside of the cylinder. There's another little tool. This is called the hamburger tester. Let me put it this way. You plug this into your PCV system, making sure that all your gaskets are sealed. And what you're going to do is under a full throttle acceleration, you're going to see where the ball goes on the scale. Can you see the ball in there? And what you've got is a perfect race motor would measure about 1.5 on the scale. If you're between 2 and 5, you're all right. If you're over 5 or even up to 7, you're going to need some work done on the inside of that motor. And what it means is that the compression gauge checks the compression in the cylinder, where the hamburger tester actually checks the blow-by, how much compression is actually going past the rings and the piston and going into the crankcase. And that's what that will monitor. But it's a very simple test to do, and that's why I like to use that also. Now let's get into these valve train components, and I'm going to show you a lot of different versions, and they're all going to depend on what you're going to do with your particular car, your application, if you will. Let's start off down here. We're going to show you the different rocker arms. Now these are of a stock nature right here. This is what most of you guys are probably seeing. Now to upgrade them, you would go to this one, which is a little heavier construction, and it also has a roller tip on it, which cuts down on friction. Now these are held down by a locking nut right here. Now your next step would be to go into an aluminum type of rocker arm. You see it right here? It's lighter weight. It's got the roller tip on the front. It also has roller bearings on the side shaft here. You see that? Now you can also get these in different, this is a 1:5 rocker arm, the ratio. The one I'm going to show you here is a 1:6. So if you wanted to increase your cam lift, you can actually do it by increasing the ratio of your rocker arm. Now this one here is what they call the indestructible one. This is of a stainless steel nature. Got that same roller tip on it with the large shaft and the large needle bearings on it. This is one that you would use like in NASCAR application where you're looking for real strength. This is one thing you don't want to have break on you because it causes a lot of damage. Now the difference is, I showed you the nut that the stock ones are held on. This has actually got a locking device. It's got a large nut, and then it's got an Allen head that goes down inside. So when you adjust these, and we'll show you how to adjust these later on, they stay adjusted longer. Now, let's get into the studs here. I've mentioned before that we always like to take the pressed-in studs out. This is the tool that you'd use to take those studs out. If you were going to do it yourself, that is. If you're taking it to the machine shop, he's using the same tool right here. He puts it on the stud, and he exerts a lot of pressure because this has got a bearing on it right here. And when he turns this nut, he'll actually pull that stud right up out of the head, and then he can go back in there and put his screw-in studs. And here's a screw-in stud right here. Let me show you this one. Instead of being pressed in, it's got threads on it right on the end here. Now this one here is a 3/8 stud. Even though the where it screws down into the head is 7/16, the actual shaft where your rocker arm goes onto is 3/8. That's fine for street application. When you're going to get into a little heavier use, here's one that's 7/16. It's got 7/16 where it screws down into the head, but up on the top here it's also 7/16. So it's much heavier, you can see that, than your 3/8 stud that you're used to seeing on your stock application. Now, not only do they come in standard, but this one here in my left hand is a case hardened one. What you're trying to do is you're trying to take all the flex out of that rocker arm as it's rotating up and down. So these here are normally found in your big block engines, but they're not of a case hardened material. This one here is an aftermarket one where they've actually gone in and case hardened them so they'll last you and have a lot more rigidity to them. Now, talking about this screw-in stud, here's the tool right here that we use to actually cut. Let me come right over here. There's a boss that sticks up, it's probably 9/16 high, and you come in with this tool mounted on your large drill, and it actually turns and spins it and cuts it right down to the proper height right there. Now, once you've cut it, you've got to come in here now, and here's the tool that's going to put those threads down in there. It's got a little guide pin. Put the guide pin through like that, and you take your tap and you get it started so it's perfectly square to the head. You run your tap up through, get a couple threads going, then you take it out and you finish your tapping procedure until you've got the threads all the way down in. Now let's go over here. I want to get into the springs for a moment. On this particular head, let me move this. We've cut the spring pocket for the larger springs. And this is the tool that you use. Now this particular tool here does two things. The outside one here cuts for the 1-inch 550 spring. The inside one cuts for the Teflon seal. And we'll show you another cutter that does that. But you may want to buy one that does both jobs at the same time, and that's what that one does. Here's one if you're going to run the real large springs. This one here, I don't think I did this head. I didn't. This one here, oh, excuse me. This is another one that cuts for just the Teflon seals. The difference is, the first one I showed you cuts for the 5.531 seal. This one here, because we ran triple springs at one time, cuts for the 0.500. We needed a little bit smaller Teflon seal, so we had to get another cutter. Now here's where these screw-in studs come in with the guide plates. You see how these guide plates actually go right here? And they hold your push rod in place while your engine is running. There's two versions of it. This is of a stock nature. You can see it's straight, and it puts, this actually is much closer to the head. I prefer the ones here that are angled up, which goes up higher on the push rod and gives you a much straighter push rod as it's going up and down. These are all things that I want to show you. You may be using one or the other at a particular time, but at least if you know that there's other ones available, you can make plans maybe in the future to change them, or if you haven't bought them already, you can go in and buy the one that we're showing you. Now here's another handy little device right here. When you've got your heads off and they're sitting on a bench, you want to take at that time and do what they call indexing the plugs. You want the open side of the plug to face the exhaust valve. Now let me show you how you do that. Let me screw this fella down in here. I've already marked this big nut here. As you can see, with the head off, this particular spark plug would be perfect for cylinder number 7. It shows right up on number 7. You see how the electrode, the open portion, is facing the 7. Now, and what you're doing is you're taking these out of the box. They're brand new plugs, so you're really not sure where they're going to be. But if you have to change them, they've got little brass washers that go on, which will change the position of the electrode when you put it in the head. Now let me see where this one comes up. Okay, this one comes up on 3. Now with the brass spacer out of it, it actually came up on 5 or 8. So you can see you can put thicker or thinner shims underneath your plug to change the electrode position. But the best time to do it is when the head is on the bench, and that's why you're going to be working on heads. So this is one thing I want you to pay close attention to. It gives you a much better burn in that cylinder. And a lot of times it's the difference between winning and losing, doing the little things that make a lot of attention. Now let's go into the push rods. I've got 2 push rods here. They're both the same length. In our particular case, they're 100 thousandths long because of the camshaft. They've both got 80 thousandths thick wall thickness. The difference is this is a 5/16 and this is a 3/8. This is something that if you are running a lot of high RPMs or maybe a stock car, you may want to go into the heavier 3/8 push rod. Let's take a commercial break right now and I'll be right back.
Don't you love that safe, free feeling you get in a pickup truck, Larry?
Yeah, nothing but you, me, the open road, a deer.
Yeah! The cow! Yeah! The ostrich! The village people! The village people?
You could learn a lot from a dummy. Buckle your safety belt.
Especially in pickup trucks.
I didn't know the village people were doing a road tour.
Now, we talked to you about the length of the push rods before we went for commercial break. This is a little tool that you're going to be using to check the length of your push rod. And what you do, you put it on over here, like this, and you take with your push rod in place and you take your feeler gauge and check to see if you've got clearance on either side. If you've got more on one side than the other, then you're going to have to alter either the length of the valve or the length of the push rod. But this is a simple little tool that you'll be using to check the proper length of the push rod. A rule of thumb would be anytime you insert a camshaft over 500 lift, you're going to be going to 100 over push rod. Now when you do that, you're also going to have to come in here and elongate the push rod hole, and this is the tool that you use. It's called a Lewis tool. You put it in like this, and you take a 5/16 drill and you walk it back and forth, and it actually takes and makes the hole longer and a little bit wider, so you've got the clearance for that push rod. Now I've got to tell you one thing. In the first shows I promised you we were going to make 500 horsepower. Well, you saw me insert a solid lifter cam, which I really wasn't sure if I was going to be able to do 500. We actually did 503 with the roller camshaft that we had in there. So I didn't want to take a chance, so the thing that I did over a weekend after I took the motor out of the car was I took that roller cam assembly out and I put it into our motor. Now let me show you the difference between a roller cam and a solid lifter cam. This is a solid lifter which rides on the camshaft right on this surface here. These are rollers. You see the roller bearings right here? They actually roll on the camshaft. It takes a lot of friction away from these two components. You can also make a much higher camshaft because of the roller following the cam surface all the way around. You'll make a heavier cam with a roller than you can with a solid lifter. And that solid lifter that we had taken out was actually about the biggest solid lifter cam we could get. but I did insert the roller back in there, so I just wanted to bring that to your attention. Now let's go over here. When we get into springs, these are spring shims. They come in 15 thousandths thick, 30 thousandths, and 60 thousandths. When you want to get the appropriate spring pressure, you could use these type of shims. Now you see how I've had to knock off the one edge of this spring. We actually go in there and we start off with either the 550 or 585 springs, and when I want to put the 650s in there, that's all I've got to do is change them in the car. But you'll notice this cut here is so you can clear the head bolt on either side of the head and also your center head bolt. These shims are too large to clear your head surfaces, so you can get in there and torque your head bolts down. And that's all you do is you take this little 1-inch mic and you mic them up. But we'll show you that as we go through how to actually check the height and get the proper pressure. I told you about these seals. I indicated to you that I always use the Teflon seals in the motor, and there's two different sizes for them. This is the one, if you've bought that gasket kit, you'll find that you've got this little O-ring type of seal which comes with the gasket kit. Then you've got a little bit better one right here. This is an umbrella type of seal right here, which the head still has to be machined to clear it, but that's of a little bit better for you than the donut one there. The problem is when it's rubber, for you guys that leave that car over the winter time and don't start it up, that rubber will deteriorate on you. So what you want to do is you really want to start off with a Teflon seal, and here's what they look like. That's a Teflon seal, and that's the tool that you use to cut it to make that seal go on there. And you tap them on. You get this little, let me grab a valve. Because you've got the little notches in the valve right here, they give you this little sleeve which goes over the valve. You don't want to nick your seal as you're putting it on. And then you take with a little oil and you just press, and you've got to put a little pressure on this to get it down. But you press on it to get it to slide over your keeper locks, and then you take it off and go to the next valve. But if you're going to do it, I'd rather have you start off, now that your heads are on the bench, with the Teflon seal. This is nothing more than modeling clay. When you get your heads put together, you've got to go in there and put, and we'll show you later on, you put 4 thin pieces of modeling clay on the piston. So as you revolve the motor over, the valve opens and closes and puts a little imprint in your clay. Now you go in there with your calipers and measure it, because you're looking for a clearance of anything in excess of 100 thousandths. I know some guys that are running 80 thousandths, but I want to keep you up to 100 or better. But that's what you use the clay for. Simple little tool. You can get it in any hobby shop. Now I want to talk to you about the retainer and the height. When you put your retainer on, you're going to be using this particular tool. Let me open it up. The shims that I just showed you, when you put the retainer on the valve with no spring, you use this micrometer to measure the distance between the head surface and underneath the retainer, so you can tell each one what type of shim you're going to put in there to give you a specific reading. And I'll give you an example. All my dimensions are 1-inch 860 thousandths. So I take the spring and put it in the machine and check it at a spring height of 1-inch 860 thousandths. And this is the tool that you're going to use to get that dimension. Now here's the different keepers. These are steel retainers. If you notice, and I'm not sure if you can pick it up on camera, the center hole in this retainer is much smaller than this one. The reason being is this one here is what they call the stock 7-degree locks. Steel nature with 7-degree locks. This one here is also steel, but it has the 10-degree locks. Now, you always want to go into a 10-degree lock only because it spreads the pressure over the top of the retainer much better. Now, I have cracked these steel retainers. So what I'm going to show you now is we've switched over to the titanium retainers. See these shiny ones right here? These are identical to these in shape. The difference is they're made of titanium and they're 1/2 the weight of the steel. When you're talking weight, just remember every time you have the push rod goes up and it collapses the valve, that's weight. So if you've got a steel retainer versus a titanium, it's 1/2 the amount of weight that spring and that push rod has got to exert pressure on. So we've switched over to the titanium, and that's what I'd like you to see you do too. Now, a lot of these pieces are not very much more expensive. That's why if you know that they're out there, like when you're ordering the retainers, the guy may just arbitrarily give you a 7-degree. When you're ordering, ask him if it's a 7 or a 10-degree. I'll show you the different locks here. I've always found that the 7-degree locks are green in color, where the 10-degree, which are case hardened, are black. You can also see how much larger they are. That's why he says this is a much better setup with the 10-degree. You could use the 7 if you're going to be under 6,000 RPMs or 6,500. These 7-degree locks work fine. But if you're going to start going up to 7,500 or 8,000, you better start off in the beginning with the right pieces there. Now, I've also found that from different manufacturers, you're going to have differences in height of your retainer. You could actually change the spring pressure by just changing the retainer, because some of these are actually at 0, some are 50, some are 100 thousandths higher or lower than each other. This is the little tool. Let me see if it won't come up. Let me do it this way. See how I can push that up and down, and I take a reading right here. So I put my locks, and those are the 10-degree locks. I put the 10-degree locks in with the retainer and check the dimension on each one of the retainers. You may find that from different companies or ones that you may have had on the bench, there's a difference in them. So they're not all the same, but this is the little tool that you would use to check them. Now, when you get into springs, this is a whole different ball game. Your camshaft manufacturer will tell you that on his particular cam, let's say it's a hydraulic cam, he wants between 80 to 120 pounds of spring close pressure. Spring close pressure. What you're doing is you're measuring that dimension, that 1 inch 860 thousandths. You're going to compress that spring to that dimension and see what the pounds are. Now, if you're going to run a solid lifter cam, they may want it anywhere from 120 to 150 pounds of closed spring pressure. And I'm bringing that to your attention because once your valve goes up and down, you're actually going to collapse that spring down to 1 inch 1 or 1 inch 2. Now your spring pressure is going to go, I'll give you an example. If it's 100 pounds open, it's 400 pounds closed. If it's 200 pounds open, it's 600, 650 pounds closed. So you've got to strike a medium as to where you're going to measure these. So the appropriate way is to measure them at closed spring pressure. Now here's your stock spring right here. This particular one probably runs between 80 to 100 pounds of pressure, and it's 1 inch right here. The OD is 1 inch 250 thousandths, or 1 inch and a quarter, if you will. Now, you're all familiar with that one because you're probably looking at them right now. This next one here is what they call a 427 spring. It's 1 inch 487 thousandths, so it's almost 1.5 inches. You can definitely see the difference, not just in height, but in width on these two springs. Now, I run the inch 550s only because they're the most readily available. Every catalog that you pick up is going to have an inch 550 spring in it. So these are the ones that we've been running for the past few years, only because they're readily available. Now this is the one here that I told you is a triple spring. That's why I had to go back in and cut for the Teflon seals. I had to actually take 31 thousandths off so the center spring did not hit my Teflon seals. This is another thing that you want to pay attention to. You want to actually put it together or assemble it and see what it looks like. Is it hitting anywhere? Do I have any coil bind? But that's another type of spring. Now this big fella right here, this is the one that I referred to, that we've started off at a 200-pound spring in the car, because I could put them on right on the bench. They're very easily to get on. This 650, I can't, because I cannot get a wrench in to tighten up my head bolts. So what you've got is I actually take them off once the heads are on the car. But this guy here actually comes out at 250 closed spring pressure. That's for those guys that need to run a lot of RPMs. This is a spring you don't want to use. There's also a difference in price between the stock springs up to a killer spring like this. A stock set of springs you can get for probably $40. A set of springs like this will run you between $250 to $300. It really depends on application. But I want you to at least know that there are different springs, just like there's different rocker arms, there's different push rods. So you're actually going to have to be well aware of the products before you go ahead and order the pieces for your particular application. Okay, let's talk about the valves. Intake valve, you've only got two choices. You've either got a 1.5 or a 1.6. That's an inch and a half or an inch 0.6. When it comes to intake valves, you've got a large choice. Anywhere from the stock one of today's size of 1 inch 7, it's actually 1.725, up to 2.080. Now in the middle there you've got a 194, 202, 205, and 208. I want to show you the difference between the two. Here's that stock 1725 valve on my right. Here's the 2080 on my left. Can you see how much more fuel I can pack into them cylinders with that larger valve? So you always want to go to the largest valve that you can, still keeping with the 40 thousandths clearance between the valve. Well, I guess we've run out of time for this program. But before I go, don't forget my motto: do drags, not drugs, and I'll see you at the racetrack.